So now we begin to talk about operators in Python. Operators are used to perform operations on values, on data types, and so on. Python classifies the operators into these groups, and I try to arrange them in order of importance to us in this course. So arithmetic operators are very important. They are the same arithmetic operations you learned in elementary school: plus for addition, minus for subtraction, star for multiplication. Very important. Star is for multiplication. You don't just put two variables together. You can't just put x space y and expect them to be multiplied, or x dot y. No, this is not mathematics. This is programming. So you have to do x times y to get the product. Forward slash for division, percentage for the remainder, star star for exponentiation or power, and double forward slash for floor division, meaning you will divide and then you round down. Assignment operators: equals, like x equal y, you will assign what is on the right hand side into what is in the left. We talked about that. And then you can combine equal with each of these and you achieve a specific function, which we'll talk about. Comparison operators: you see, double equal is to check for equality. Single equal assigns. Very common mistake. Please don't join the community of guys who do this. Make sure whenever you're trying to check if two variables are equal, use two equals. If you use one equal, it will just assign what's on the right into the variable on the left. Less than is straightforward. Greater than, not equal to. Greater than or equal. Less than or equal. Also have logical operators and checking if two variables, if both variables are true. Not if both Boolean variables are, not just negates whatever it was. So if it was 0 or false, it becomes 1 or true, or it compares to logical operators and it will evaluate to true if they are both true or if one of them is true. Identity operator: you can check if one object is of another type of object. So is can be used to check if an object is of the same class as another. Is not is the opposite of that. There is a membership operator which we can use to find if, say, 5 is in a list of 1, 2, 3, 4, 5, in which case the answer will be yes, meaning true. Not in, the opposite of that. We also have bitwise operators which are listed here. And for now, we're going to focus on the arithmetic operators, which are I talked about already. X equals 11 assigns 11 into x. X equals 5 assigns 5 into y. We can print the sum of x and y, right? X plus y, 55. And you know Python runs step by step, starting from top to bottom. So the first thing you're going to see when you run this code is going to be what? When you do x plus y, 16, right? The next thing you're going to see is 11 minus 5, right? Which will be what? 6. Then the next you will see will be x times y, 11 times 5. X divided by y, which is 11 divided by 5. Remainder when 11 is divided by 5, right? What's that? 1, right? Remainder when y is divided by 11. When y, which is 5, is divided by x, which is 11, correct? 5 over 11. So the remainder will be 5. X, right, which is 11 raised to power 5. That's what this is. And the last one here is x, which is 11 divided by 5. And then you round down. So 11 divided by 5 is 2.2, right? And then you round down, so it's going to be just 2. X is y plus 6. What is y? Y remains the value from the last time it was evaluated, right? Y is what? 5. So 5 plus 6 is 11. So you add 6 to 5, you get 11, and then you assign that into x. That's how it works. And when you print x, you will get 11. This is the plus equal that I talked about here. Adding the arithmetic operator to equal. So it's an assignment, which is what I talked about here. When you append equal to any of the arithmetic operators. So you put plus before the equal. So what it does is equivalent to x equals x plus y. So instead of writing this x a second time, the figure, you can remove this x, then take this plus in front of the equal, and then it becomes x plus equals y. You can do the same thing for minus. This should be minus, right? Fix this in your stuff. So this is minus. So we don't need to repeat this x, then take this minus in front of that. X minus equals y. So x plus equal y will mean x equals x plus y, and x is 11, and then we add 11 to 5, and you get what? 16. And then that 16 is stored into x. And then when you do x minus equals y, you're doing 16 minus y, which is still 5. That will give you 11, and then you assign the 11 back into x, and x is back to 11. So what you should do is to create another cell and then do these operations one after the other on your computer and get that practice. So to do that, you will click this plus button right here, and then it puts a fresh cell, and then you can do your calculations here and print it out one after the other, right? Because if you run all of these, then you get lots of output, and you need to keep track of which print corresponds to which one. It's just sequential, right? So this first one, x plus y, is 16. The next one, x minus y, is 6, and so on. So now we're moving on to the comparisons. If you do x equal y, you are comparing x with y. Is x equal to y? And obviously there are different variables, right? They contain different values. One is 6, the other is 11. One is 5, the other is 11. So the answer is false. So it will print false. That's what you see here. Prints x not equal y. Is x not equal to y? Obviously the answer will be true, right? Because x equal y was false. So you just flip the operation. Print x greater than or equal to y. X is 11, y is 6. So the answer is true, right? Then you have logical operators, the not, the and, the or. So x, we've changed it now from 11 to 5. Print x is greater than 2. Is x greater than 2? 5 is greater than 2, right? So the answer is true. And you're going to combine that with x is less than 9. So is 5 less than 9? True. So true on the left, true on the right. So you're saying true and true. That will evaluate to true. It's product of +1 and +1 basically is 1. So that gives you true. It will return true and will return true if both statements are true. How about or? This is true, right? But this one is false, right? X is greater than 3. It's not less than 3. So you have true or false. And or will give you true if either of the two are equal, or if both of them are true, I should say. So you can read those here. So true or true will be true. True or false will be true. False or true will be true. But false or false will be false. Not will swap whatever the Boolean value is. If this evaluates to true, not will make it evaluate to false, and vice versa. So x is greater than 2 and x is greater than 9, which was what you had here. So now you have an operator precedence. When you have this, you have to evaluate what is inside the parentheses first. Then you move on outside, which is your PEMDAS, right? Parentheses first, before exponentiation, before multiplication, before division, addition, and subtraction. So we'll evaluate what's in the parentheses first, which is what this is, and that gave us true, right? So when you do not of true, then it becomes false. So the last printout will be false, which is what you see here. Operator precedence, which I already just mentioned, follows. It's similar to your PEMDAS. And then because P is parentheses, if you need to force anything, surround it with parentheses. So if you want it to be, some part to be executed before others, put that part in parentheses. It has the highest precedence. So addition, subtraction have the same precedence in Python. Multiplication and division have the same preference. So it will just be executed from left to right. So I don't think addition comes before subtraction in programming. No. Same with multiplication. Multiplication doesn't come before division. They are evaluated just from the left to right in sequence. So if you want to be sure that your calculations are right, if you have multiplication and division, you want to surround them with parentheses to force the sequence. And that's mentioned here. It's a good idea to use parentheses so that it's clear on which portion of the long linear algebra gets executed first. Then we have formatted string literal. So far we've just been printing with print command, and then we put whatever we want to print in the print function arguments, meaning what you put inside these parentheses. We can control it so that we can have more informative printouts instead of just true, false, and that's it. We can indicate what calculations yielded these results by putting in some words, some text before these printouts, like so. Well, these are F strings or formatted strings. They always start with F, which is why they're called F strings. You can use double quotes, single quotes, same deal. Python, you will see a lot. Anytime you have double quotes, you can also use single quotes in place of it in most cases. So most efficient way, the most practical way, and also the simplest way to format strings is to use F strings. It means instead of just having double quotes and printing out stuff, before the double quotes put the F, right? And so normally everything else will just be a string. What is different with this F string, just because you've put an F before it, you can go anywhere in the middle of the string and then put curly brackets. And whatever you put inside the curly brackets is going to evaluate the variable names or the values you put in there. So this will function like a standard Python code. Same here. So it's going to evaluate the product of X and Y, and then put that product here. So it's going to read the product of X and Y is the number, which is the product of X and Y. It's not going to write this out there. While the difference between X and Y is, then it will evaluate what X minus Y is and put that in place. So you can run it, and this is what you get. So the product of X and Y is 25, because the last value of X and Y is 5 and 5, right? Y never changed from 5. So X is now 5. So product of X and Y is 5 times 5, and it just writes that value there. While the difference between X and Y is 5 minus 5 is 0. It works with double quotes, it works with single quotes. So this is what I will want you to use a lot. You will be doing this in your labs and your finals. So take some time out to really understand the sequence. Normally you will have done print, and if you want to print a string, you will print a string here, X plus Y. So if you print this, what are you going to get? You will get X plus Y. It's not a variable, it is a string. You want to convert it to F string, you put F, a formatted string, before this, right? And if you run it, you get the same thing because you have not done any calculation. You've not used curly brackets yet. Now, what you can do with curly brackets is you can do X plus Y equals And then you can open and close your curly brackets and do x plus y, or really any mathematical operation whatsoever. And now if you run this, Control Enter, now it says x plus y corresponding to this string equals, then when it gets into the curly brackets, it just evaluates the value. The calculation in there, and you get 10. And that's how that works. And that brings us to the end of Lab 1. With this, you should be able to work on your Lab 1 workbook.